So again, tomorrow I will be sending you an email. One of the things in this email, I just got sent this a while back, all right? And it says, want to learn programming, 5 key terms you should know. You can find these articles anywhere and everywhere on the internet. I get that. All right. Number 1 says, before you start, relax. The key to being able to program and program well is not to memorize everything. It's virtually impossible to do that. I say virtually because really nothing is impossible. We had a gentleman who worked here. None of you knew him, except Evan may have. The guy who used to have Brock's job, Brock, the guy who comes in after us, he had a photographic memory. He went to take this certification test, knew nothing about it, read an 800-page book the night before, went and took the test, and basically got 100%. I don't know how people can do that, but some can. Maybe I could do something similar when I was younger, not that well. All right? But the point is, don't try to memorize everything. But know where to look when you've got problems. I already mentioned to you that when you get started, you might want to go out to the W3 schools and go through their tutorial. When you have problems or when you have issues or if there's something you want to look at, I showed you that Mozilla site. I'm not going to do it, but as you'd probably guess, if I were to come out right now and go into Google and type in JavaScript, my guess is I would have somewhere between, 300 and 500 million hits. And you know that much of that stuff is going to be good and much of that stuff is not going to be so good. All right? So, first thing is text editor. I'm not going to talk about that. Again, you can use the one you have. Now, one of the reasons I decided that I'm going to go and work with you and we're going to build a website as a class is one of the things this is going to allow me to do is to teach you wireframing. And the tool that we're going to use for wireframing is the one that I showed you or started showing you yesterday, that Balsamic tool. If you can learn Balsamic, again, not memorizing it, but if you've got a comfort level using it, next semester when we use an actual IDE, an integrated development environment, when we use Visual Studio, you're going to get it literally like that. Because it's probably about 75% of the stuff you'll learn with Balsamic you'll be able to apply directly to Visual Studio. So you've already learned 3/4 of it. All right. So the difference is with an integrated development environment, what you get is you get things, as an example, you get what's called IntelliSense. So when you start typing something in an IDE, if the system recognizes what you're trying to type in, it'll finish it for you. Doesn't mean you have to accept what it says, but a lot of times you can develop things faster. It color codes things for you. All right, you probably have seen some of that in the editor you used or the editor that I've used. All right. Here's a key one. Again, we are learning a scripting language. All right. We're also learning what's called an interpreted language. JavaScript is not compiled, it's interpreted. The difference is, I've given this kind of example before, so if I have given it to you guys, sorry. But if you've got two people who are conversing, all right, or two people who want to have a conversation, and they speak different languages, all right, and then they get an interpreter to be able, so they can interpret the language. So the first person starts talking. If every time that person talks, and the interpreter doesn't know what that word is, they say stop, and they've got to look it up before they can go on. That's an interpreted language. The reason I'm telling you that is with JavaScript, what the system will do is if you write a JavaScript program with 30 lines in it and you've got 20 errors, it'll stop as soon as it finds the first error. You have to fix it, and it'll show you the second error, and then you fix that, etc. Sometimes, depending on what if you're using an IDE or whatever, it may show you a whole bunch of errors. You're always best off, if you have errors, to fix them from top to bottom. All right? Not to just say, oh, I know what that one is, and just start in the middle. Okay. All right. Software frameworks versus software libraries. Good news is you know what these are. You've been using a framework. You used a framework for your midterm. That framework was Bootstrap. All right? What you're going to learn a little bit later on this semester is a software library, and that's jQuery. So as they say, a library is a reusable piece of code you can integrate into your project to perform a task. In an ideal world, we'll have enough time where we can see how everything fits together. Then in this semester, you will have learned HTML, CSS, Bootstrap, JavaScript, and jQuery. All right, that's what you're supposed to get out of this class. All right, finally, when I used to teach this class, in fact, back when I was your age, hard to believe, but yeah, one time I was that age. All right, we had to do stuff like this just to show you it. Oh, where is it? I have one. Oh, I used to have a real good picture, and I don't know where it is right now. There. We had to use these things. And we got pieces of paper that were literally about maybe 18 inches high and about 18 inches wide. And before we were allowed to create our programs, we had to use these symbols and flowchart, which was a pictorial representation of what we were trying to do. All right? Then, after we did that, our instructor would say, either that's right, and he would give us, or she would give us, the data that we were going to use for the program, or she or he would say, that's wrong, go back and fix it. All right? Not what we're doing today. Okay? Then we kind of went from there, we went over and started using, I don't know where I've got my stuff now, but we started using something that's called pseudocode. And if you say, I don't know what pseudocode is, it's sort of a fractured type of English that is, again, sort of English and sort of a programming language. It looks like this. I know that's a little hard to see. But the idea is, as an example, when I was in the IT field, all right, I went from one job to another job. And one of the first things they asked me to do was to build this order entry system. And I said, fine, what language do you want it built in? They said, what do you know? And at the time, I probably was fairly good in 7 or 8 languages, so I named them. And they said, yeah, those are fine. I said, well, which one? Oh, you pick. All right? The idea is I could write pseudocode, and if I had good pseudocode, I could write it in any of those languages. All right? So unlike flowcharts, which are pictorial in nature, this is textual in nature. All right? All right, then let's jump into Chapter 2. Somebody will let me know when it's 8:55, 12 minutes, we're taking a break. So, Chapter 2, getting started with JavaScript. Look what's in here. How to include JavaScript in an HTML document. It says 2 ways, okay? There's 2 ways of doing it. In the head. There's another way of doing it inside of the document. Just like we had 3 ways with CSS. Remember we had the inline CSS where we put a span tag and we put something in there. Then we had the style tags in our head section. Then we had the external.css file. Pretty doggone similar. Doing it with JavaScript. Then we'll start looking at syntax. There are certain rules that you have to follow. All right? And then how to work with JavaScript data. We'll talk about the different types of data you can use. This, how to use objects, methods, and properties, that's getting pretty heavy already. All right? We will look at those, but we won't talk about them until way later on in the semester. Then there's 2 different applications. There's a miles per gallon application, and there's a test application. All right? We're going to spend a little bit of time going over those because one of your first assignments is going to be to modify that miles per gallon application. All right? So we'll look at all that. All right. So if we look in here, if I put this line of code up in my head, I can either put this line of code in the head section or in the body. You saw when we used those script tags with Bootstrap that we put them all in the body. That's what most books recommend. Because if you put your JavaScript in the body section, whatever is come above before it has been loaded into memory. So the recommendation is that you do that. Not everybody does. All right? But if you do, notice the way we have to do this. This is a beginning script tag. This is an ending script tag. The only thing you need to put in the script tag is source equal. And if you remember, when I had you create your folders, we created a JS folder. That's where all your JavaScript is going to be. You are going to be mandated by your instructor. So for us, here we would say js/calculatempg.js. All right? I want you to do that. Why? Because that's the way people do it. All right? But this, whether we put it in the head or the body, this is a way to bring in an external JavaScript file. This, in our head section, that's bringing in an internal JavaScript file. Just like we had our style tags when we were working on CSS. We're not going to do that. We'll probably never do that. All right? And there is yet another way that you can do it. So, you know, if I wanted something to happen, what comes after the head section? The body, right? I could say body, and I could say, for example, onload equals, which means when the body comes into memory, I could give it the name of a .js file. So I could tell it to run then. We're not going to do much of that either. Virtually everything that we're going to do, we're going to have an external file that's going to hold our JavaScript. Now, when you look at this stuff, I'm not saying, hey, does this all make sense to you? What an alert does is on the top of your page, it puts up a little box, a little alert box that says the Calculate MPG application. You click OK and that goes away. Then it's going to bring up literally a prompt, so it's going to bring up a message that says enter miles driven, and you put a value in there. Then it'll bring up another box that says enter gallons used, and it'll put a number in there. Then it'll divide the first number by the second, all right, and it'll give you your miles per gallon. Now, is that big a thing? Kind of. So what I'm going to do is I'm going to grab every bit of this. Whoops. See if it let me grab every bit of that. Still going to try it. Let's see if it grabbed it or not. No. All right. Then we'll worry about that after the break. But the point is, if I ran this, what I want you to get out of this, what if it comes up and it says enter miles driven? What if I leave it blank? What if I put nothing in there? Or I put, I don't know. I'm going to have a problem. All right? And this is one thing, you don't have to write it down, but you have to know what this means. Anybody have any idea what that might mean? NaN? No, it's not your Nana. Yes? Not a number. So if JavaScript is expecting a numerical value and you put something that's non-numeric in there, you'll get NaN. Not a number. You can test for that too. We will be doing that. All right? All right. And then they say how you can include it in the body. Notice what they're doing. Inside of the paragraph, they're putting script tags. This is considered a bad idea. Why? Because in many ways, what you're doing right there is you're doing the same thing as taking CSS and putting it right inside of your HTML directly. That's considered bad practice. Now, you can sometimes make the case, well, that's the only way I could do it. Okay, that isn't the case here. They're just showing you an example of how it can be done. All right. And notice you've got this, the no script element. All right. So notice here it says no script, and it says no script. All right. The reason that you put in a no script element is it is totally permissible for a user on their machine to turn JavaScript off. And if they turn JavaScript off and you've got JavaScript code in there, it's totally ignored. But if you put a no script tag in there, you can at least give them a message that says, hey, your JavaScript is either, it's enabled or something is wrong. In order to be able to really be able to do all this stuff, you want to enable it. You want to know how to enable and disable, we're going to go over that in a later chapter. All right. The next thing that's in here is JavaScript syntax. And I'll tell you what, this is actually a good place to break. So even though it's only 8:50, let's come back at 5 after 9, and we'll pick it up right here, please. Yes.
I'm having trouble logging into my files data, and I thought last time I moved everything over, right?
Okay.
Is it that you drag this from here to there?
No.
No.
Your problem was could not connect. That almost always, I'm not saying that that's what it is there, but it's almost always either you put in a wrong password, or you put in something wrong here or here or here. I mean, it's one of those. That's almost always what it is. So we'll take a look at. Just give me about 15 seconds, and then let's see. Now I can come in here. All right, then continuing on, they talk here next, I'm on page 56, about JavaScript syntax. You know what syntax is. You know, for example, from the time you were given your first writing assignment, I don't mean in kindergarten or first grade, but your teacher told you to put periods at the end of sentences, to put commas, to separate thoughts, to indent paragraphs, or whatever. Programming languages also have their own syntax. Now, I told you this yesterday, but I'm going to repeat it again. The recommendation is at the end of every executable line of JavaScript code, you put in a semicolon at the end of the line. 99 times out of 100, if you don't put one in, you forget to or just don't, it works right anyway. Occasionally it won't, but we're not going to cover that stuff for a week or two yet. All right? But that's part of the JavaScript syntax. So if you look here, here are the rules. JavaScript is case sensitive. I mentioned to you yesterday that if I'm writing a JavaScript program and if I say in there as an example, var age equals 21, where age is all lowercase, then later on in my program I make age in uppercase, and I set it equal to 65, those are two different variables. All right, JavaScript is case sensitive. So in other words, I mentioned this routine to you yesterday. Get element by ID. The biggest problem that people make with this is they type in get element by ID. Those are not the same thing. It's a case-sensitive language. Most languages are case-sensitive, all right? And they expect things to be done in a certain way. So that's the first thing. Second, each JavaScript statement should end with a semicolon, all right? Third, JavaScript ignores extra white space within statements, but that they should have put a caveat, a thing on the end there that said most of the time. All right? Next, how to split a statement over two lines. I'm not going to go over these because you're not going to remember them anyway. The best way that you learn this stuff is by going through some examples. All right, we're going to do that after we go through after our next break. I've written one already, but for some reason it's not working. I'm going to debug it, and then we will go over it. I will give you the code, and we will go over it line by line. All right? So a JavaScript statement has a syntax similar to Java. Does that matter to you? Not right now, but considering that when it's next January of 2020, you'll be taking a Java class. And virtually everything that you're learning here, syntax and otherwise for JavaScript, you'll be able to apply directly to Java. Are there differences? Of course there are. There are. There are two different languages. All right. In some cases, it says JavaScript will try to correct when you make a mistake. All right. And usually it'll get it right, but not always. Identifiers. Look on the screen, please. Identifiers are things you make up. They're names of variables that you create. They're names of functions or methods that you create. We'll talk about those in a bit. And if you're using objects in JavaScript, they're the name of objects that you create. You've got to follow certain rules, such as what you create can start with a letter, with a number, with an underscore, or a dollar sign. My recommendation, never start it with an underscore, never start it with a dollar sign. And if possible, if you have it contain only letters, then you have nothing to worry about. All right? Now, I mean, if you decide here that you're going to have 3 ages, and you want to call them age 1, age 2, and age 3, of course you can do that. But you can't say first age, because you're starting it with a number. That's illegal. All right? Second, as already mentioned, these again are case sensitive. They must start with a letter, can't start with a number, and they can only hold this stuff. They can be of any length. The other thing I'm going to mandate that you do is when you create variables, almost all the time, the variable has to be reflective of what it is. I don't want you to say, age 1, var age 1 equals 21 is fine. Var Ralph equal 21 is not fine. All right? And that should just make sense to you. Because what you're going to end up doing is you do some self-documentation, all right, when you give your variables good names. All right. They can't be the same thing as Java reserved words. Someplace in this book, they give you the Java reserved words, or JavaScript, I should say. If you want to know them, I can just come up right here and type in JavaScript reserved words, and they'll give me a list. All right. Now, I don't expect you to memorize those or anything else. Some of these words, too, just so you know, the reason they're reserved is they don't want you to use them. They have no meaning, but they don't want you to use them. I have no idea what I'm about to say if this is anybody in here. But back in the olden days, all right, when I was more your age, usually the first language that people got taught was BASIC. Not Visual Basic, BASIC. All right? And in there, when you got in trouble, you made a go-to. All right? And the way I use go-tos, or the way I explain go-tos, I'm going to guess in here that everybody in this class at one time or another, and maybe I'm wrong, you've seen the Roadrunner cartoons, Roadrunner and Wile E. Coyote. All right? And, Wile E. Coyote has finally got the Roadrunner trapped, right? And he's about to swoop in on him. So what happens? Magically, a paint can appears next to a rock that he's at. And he goes and paints himself a door or something else, and he goes through it. And then Wile E. Coyote tries going through the same thing, and then it's a rock again. Well, having that magic paint, etc., that's a go-to. You can just say, hey, I know it's wrong, but just go to another part of my code. That's the way people used to program. And you get what was called spaghetti code, because you'd be going all over the place in your code, and you'd be doing things that you weren't supposed to do. That didn't stop people from doing them anyway. So go-to is a reserved word, but it has no meaning. They just don't want you to be able to use it.
People still use it?
Bad programmers do in some languages, because most programming languages allow you to use at least some form of goto. All right. Notice the word var is a keyword. So you can't say var and then give it a variable name of var. You couldn't say var var. You'd get an error message when you try to run the program. Oh, I guess I could have done it right there. There it is, on the bottom of the page. There's the reserved words. Again, you don't have to memorize those. Comments. Okay, 2 things for comments, just so you know. You've seen some of this. Does everybody remember when you made comments in CSS files, how they look like this? You put in some stuff, and you end it like that. That's how you do a multi-line comment in JavaScript as well. Single line comments, if you put in 2 forward slashes, everything to the right of that automatically becomes a comment. So if you do it at the beginning of a line, boom, everything else is a comment. What's a comment? It's something that's ignored by the system. Literally, you typically put comments in there for yourself, to explain why you did something or whatever. You can comment in and comment out code. The biggest takeaway, so to speak, I want you to get out of this part of the class is, let's say I've given you an assignment. You understand what the assignment is, okay? And the assignment's got 4 parts to it. So let's assume for a second that it is a miles per gallon program. So the first thing is you have to input your miles driven and your gallons used, all right? So let's say those are 2 different routines. So you got to input miles driven, input gallons used. Then you have to figure out your miles per gallon, then you have to print it. Does that all make sense? So it's 4 things you have to do. What I don't want is I don't want you to write every line of the code and then start testing it. No. Write the first routine to input your miles per gallon, test it, get it to work. Then write your second routine, test that, make sure you didn't break what you've already done. That's the way that professionals code. They don't just sit there and write hundreds or thousands or whatever lines of code and not test it. All right? Now, JavaScript has very few data types. How few? Those. It basically handles all numbers the same. Doesn't matter if they're a whole number or a number with a decimal place. They're just numbers. Strings are anything either in double quotes or in single quotes, but you can't mix them. You can't start with a single quote, end with a double quote, or vice versa. All right? What's a string? It's a bunch of characters. Even if I make a string like this, that's not the number 123. That is the string 1, 2, 3. Just the same way that when people give the address of this place and they say 751 or 755 Par Road, that's not really a number, so to speak, because you can't use it arithmetically. This has an arithmetic value of 0. Now, you can convert it into a number. We're not going to talk about that right now, but yeah, you can do that. Booleans, I've already mentioned, are true and false. If a value is a whole number, it's considered to be an int or an integer. If a value has a decimal place, it's considered to be a floating point number. Normally, they're either called floats or doubles. Again, you don't have to worry about memorizing this stuff. I'm just giving you some wordage. All right? Strings, again, double quotes or single quotes. Booleans, again, true or false. In some programming languages, a Boolean can have 3 values. It can have true or false or null, which means you don't know what it is. All right? Now I'm not going to pick on him. I just happen to be looking at it. With Chris. Let's say I didn't know Chris, and I got a thing saying, hey, Chris Hardy's going to join your class. Didn't say Christopher, didn't say Christine, just said Chris. I would not know if Chris was male or female based on that. I have a sister, Christine. The only time I've ever heard her called Christine is when someone is really pissed at her. In fact, if anybody calls her Christine, she corrects them. All right, but the point is, in that case, I would set his gender probably to null, meaning unknown. You can't do that in this language. All right? So a Boolean must be true or must be false. If I said to you right now, I'm not, but if I said this to you right now, if I said, as an example, let's grab this one. Okay? And I said, hey, Luke, how do you read that? You'd probably say, well, var count equal 1. All right, so you're setting count equal to 1. Yeah. Literally, the equal sign in JavaScript and in most programming language, a single equal sign means assignment. So that says assign the value 1 to the variable called count. It's not an equality thing. When you check for equality, you use 2 or 3 equal signs. All right, that is assignment. So single equals is assignment. All right, just keep that in mind. You can do this, and instead of having it in one line like this, you can put it in 2 lines, like they show here. Okay, why would you do that? Well, if I was writing a program and I wanted to be able to enter in the number of people I had in a class, and I wanted to run that program for, let's say I have 5 classes. Maybe one class has 10, one has 20, one has 30. I might have to ask the user at the beginning how many people are in the class. Otherwise, it makes much more sense if you know what the value is to do it in one line. Okay? Just so you know, I'm giving you verbiage. See this line right here? In blue, where it says var counter? That's called, all right, variable declaration. I am declaring a variable right there. The next line here, that is called variable initialization. I'm giving it an initial value. This is called variable declaration and initialization. So you can do it as 1 step or you can do it as 2 steps, whichever you need. And that's, again, I don't want to sit and read what the author says. You can read that stuff yourselves. All right, arithmetic expressions. You know, most of these are ones, whoops, can't have them there. Okay, there we go. Most of these are ones you've already seen. You know what addition, subtraction, multiplication, and division is. You all know that. All right, the modulus, you may or may not know. If I say to you, remember the old-fashioned way we did this back in grade school? You said 7 divided by 3, and you put a 2 there, and you got a 6 and a 1. You might say something like that, 2R1, 2 remainder 1. That remainder, that's what you get with modulo. So most often when you use modulo, it's for things like you're breaking dollars into the number of cents, or you're doing, you give them minutes, and you want to know how many hours and minutes and seconds that equals, etc. Something like that. There's also these, all right, that adds 1 to a number or subtracts 1 from a number. We'll look at it now, but just so you see it, so if I say this, var age equals 21, all right, if I say either plus plus age, or if I say age plus plus, now age is 22. Does that make sense? There's actually, if I want to go and add 1 to age, I can say age equal age plus 1, or I can say plus plus age, or I can say age plus plus, or I can say age plus equals 1. Any one of those 4 things will add 1 to it. But when you use plus plus or minus minus, you can only add or subtract 1. That's it. If I want to go and add 7, you can't do this. Can't say plus plus 7 or age plus, then it wouldn't work. I have to do it like this or like this. All right, just again, I'm just throwing some stuff at you. Everybody in this class is going to get hit with some kind of a weird error at some time or other when we start writing programs. It happens to everybody. All right. The good news is, typically, if Chris has an error, he can say to Chase, hey, can you look at this? Chase will love to find Chris's error. And the good news is, Chris will be able to pay him back later. All right, that's how it works. And, it's funny, if you remember this thing I gave you that we started here, this thing, this want to learn, and number 1 said before you start, relax. If it's a lab day and you're working on a problem, okay? So Justin's working on this problem. He's getting this error, and he doesn't know what it is. And he's like, the hell with it. I'm not asking Evan. I'm not asking Luke. I'm not raising my hand and asking the teacher. I want to figure it out myself. And he looks at it, can't figure it out. The best thing to do, walk out of the room for 5 minutes. Just walk away from it literally for a couple minutes and walk back, all right? All right, they give you examples on how to use these expressions. The plus, whether it comes before or after the variable, there is a difference. I'm not going to go through that right now. You want to see it, you can go ahead and take a look at it. Not only can you use that plus equals that I showed you, you can use plus equals, minus equals, times equals, divide equals, and modulo equals. Is that big a thing? No. When you are first learning, when you are in your first semester, what you should be coding when you're starting to write code, you should be coding for understandability. You should code in the way that it makes sense to you. Not that you write it in the most smallest way possible, the most, etc. You might not write the best code, but if you write code that you understand, that's good. That's much better. All right. Concatenate means to glue things together. So if you look up on the screen here, you've got first name equal Grace and last name equal Hopper. If I asked you in here, if I said, does anybody know who that is? You'd probably say it's probably something they made up. No. Grace Hopper is one of the greatest computer programmers of all times. She was a woman who was in the Navy. She was about 4.5 feet tall, yet she was, I believe, a rear admiral. And yeah, I've seen her. I think she's been gone for many years, but I've seen her on different clips and stuff. And she just demanded respect. The point is, we've got two variables here. One called first name with a value of Grace, one called last name with a value of Hopper. If I want to put in her last name with a comma and her first name, I can do it like this. Last name plus, which means concatenate, a comma and a blank space, and then the first name. So putting in that line will result in Hopper, comma, Grace. These escape sequences, if you want to force, this is the one you're going to use \n 90% of the time. If you want to create a new line, \n. It's like you hit the enter key. If you want a tab, \t for tab. Those are the two you'll use more than 99% of the time. All right, this stuff, objects and properties, this is way over everybody's head. The only thing I do want to mention in here are these two things, alert and prompt. Alert is literally what's referred to typically as a message box. If you want to give someone some information, you give them an alert. If you want to ask somebody something, it's a prompt. Don't worry about print right now. That's not a big thing. All right. We will use parse int and parse float in just a few minutes to try to force something to becoming a number. And if it's not, as we talked about before, Tom mentioned, he said NAN. I don't know why this isn't catching up, but it's not. All right. And NAN for not a number. All right. We'll use write and write line. The difference is if I say document.write. So if I say document.write and I put in here Jeff, then it's going to write Jeff and the cursor will be right there, right at the end of the line. If instead of write I say dot write line, then it'll write that out and the cursor will be at the beginning of the next line. Only difference between them. All right. Now, what they do next is they give you two applications. I don't expect this to totally make sense to any of you. All right. The good news is, or if you, I don't know if I call it good news, you all have the same look on your face right now. Like, God, take me, God. I just want to be anywhere in the world but right here. All right. And I get it. I went through the same thing. I was where you were at one time. All right. Well, let's take a quick look at these two, then we'll take another break. So this would be a miles per gallon program. This right here is a prompt. You're asking the person to enter the miles they've driven. So, for instance, they put in 275 there. If they click OK, then that's probably going to be copied to a variable someplace. Then it'll ask them for the gallons used, and it'll do the same thing. If you click Cancel there, what happens? It depends on what you've programmed or not programmed for. So we're not going to worry about that right now. But if it comes up with a prompt, and it says enter miles driven, and you type in this, and then it comes up with another prompt that says enter gallons used, and you do this, then you'll divide 273 by 12.5, and it'll give you your miles per gallon. And the way you do that is shown right here. That's it. All right? So as it says, if an application pops up, yeah, don't even worry about that. Here's one with test scores. So the idea is we've got 3 test scores. So we let the user enter 3 different test scores. We add the 3 up, and we divide by 3 and give you the average. Now, a couple things about this. First of all, might sound real simple. All right? But notice right here, because this is what most people do. They say total equal test 1 plus test 2 plus test 3 divided by 3. That'll result in an error. So let's assume we're going to keep it simple. You got a 70, then an 80, then a 90. So what I want to do is add those 3. So I want total to be 240. I want to divide that by 3 and get 80. Does that make sense? So if I say, total equal, in fact, not even total, let's make average. All right, that's what I want. But what the system does is it says, oh, we do the first thing that we do is division, because division you do before addition. So we take test 3, which is 90, and we divide it by 3 to give us 30. So what we do is we say 70 plus 80 plus 30, which is 150. So instead of giving us 80 for the average, it gives us 60. All right? And you look at it, well, I couldn't get a 60. I got better than that. No, it's because of the way you put this. So how do you force that? You use parentheses. That's it. Yes? Depending on how you're writing it, yeah. All right. So again, that's it for Chapter 2. And I'm not that dumb where I'm going to say, hey, does that totally make sense? You're getting a lot thrown at you in a very short amount of time. Let's just take a minute and go over the summary that's in here. All right? If you put your JavaScript in its own file, doesn't have to be in a JS folder, but that's what we will do. That's called an external JavaScript file, the .js for JavaScript. So you have to use a script tag to include it then in your program. All right? JavaScript has syntax. All right? One thing about this, just so you know, and I didn't mention this before, but I want to right now, and that is this. That if I come in through here, let's say that I'm going to create a variable, and I'm going to call that variable tax rate. Usually you write it like this. Let's say that it's 30%. Or you write it like this. One or the other. If you write it the first way, where the first word is lowercase and the beginning letter of the second word is uppercase, that's called camel casing. All right? If you do it the other way, where you use an underscore, there's no real name for that. Not all languages allow you to do this. In some languages, you can't use an underscore. You can in JavaScript. I would recommend that 100% of the time you do it the first way. Why? Because that'll make it easier when you go and transition over to other languages that don't allow you to use the underscore. All right? Again, JavaScript has 3 primitive or built-in data types. Numbers, which handle both whole numbers, called ints or integers, and decimals, what are usually called floating point values. strings, which are in double quotes or single quotes, and Booleans, which are true or false. All right. The equal sign is an assignment operator. All right. So var age equal 21. Take 21 and assign it to the variable age. All right. We looked at the arithmetic operators, the addition, subtraction, multiplication, and division. We also added onto there our plus plus and our minus minus, which are typically called auto increment or auto decrement, to either add one to a variable or subtract one from a variable. We also looked at the percent sign, which is used for modulus. All right, the remainder operator. We saw how you could glue together two different strings by using the plus sign. The plus sign then is known as concatenation operator. For the objects and methods and properties, the only ones we looked at for now were the prompt, which is asking the user for some information, and the alert, which is giving the user some information. All right? And like I said, I know this stuff, I'm not going to lie, I'm not going to say it's easy. Is it fun? Once it starts making sense to you, I think it is. All right? Now, does that mean you will? Hell no. All right? But it'll I think it'll work out a lot better for you when it does make more sense. All right? So, even though it's early, it's 9:36. Let's take 14 minutes and come back at 9:50. Then we'll go over Chapter 3.